Okay, dear student, let's go for this now. The electric field lines can cross each other. They are parallel to equipotential surfaces. They are directed from negative to positive. Show field strength by their density. Okay, so first of all, we must understand what is the electric field lines, what are the gravitational field lines. People, I think, not the electric field line, but the gravitational field line. Like we are doing the same topic in the topic D1 also, which is freely available as lectures on the YouTube channel. So the link will be there at the end of the video. You people can check out those lectures. Like the complete playlist for D1 will be there. Okay, you can check it out. So the characteristics of the gravitational field lines, they're absolutely same as the electric field lines. Even the gravitational equipotential surfaces and the electric equipotential surfaces almost same. Of course, there are a couple of differences, but you can understand the majority of the things. Okay, now the electric field lines. So electric field lines are, how are they defined? First of all, they are defined as, like, let's say this is the line. This is kind of like the electric field that we have shown somewhere in the space. So how is it defined? Technically, it is defined as it is the curve tangent to which at one single point, like this, tangent to it at one single point is going to give you the direction of electric field at that point. This is how we define it, and this is how it looks like. So it could be anything like this, and then you can find like what is the direction of electric field at this point. It will be tangential here, like that. So whatever be the direction. So point number one, can they cross each other? Well, this is the first feature. They can never intersect each other. Why? Because if they will be intersecting like this, so there will be two directions of electric field at one point, because there will be two different tangents to two different curves at the same point, which means that electric field is having two different directions, which is of course not possible. So we have to say that they will never be intersecting each other, no doubt about it. Now after that, they are parallel to equipotential surfaces. Well, of course not, because equipotential surface is supposed to be something like this, that it is always having 90-degree angle with the field lines. Everywhere it will be 90 degrees, everywhere. I know the diagram, it does not look like that, but it is 90 degrees. You can take the example of a simple spherical field line, kind of wavefront kind of a thing like this. And these are the equipotential surfaces. So you can see equipotential surface is always 90 degree to the field lines. So even B option is wrong. See, they are directed from negative to positive charges. Well, this is absolutely wrong. Why? I have given you one definition for what is the electric field line. There is another definition for electric field line. What is that? Let's say I have placed a very small positive charge here. So electric field lines, they are also defined as the path traveled by a very small positive charge when it is placed in the electric field. So the path traced by it will be the electric field line. So this is a positive charge, and of course this is also positive. So that is why we say that they are always directing away from the positive source charge, because the field line is the path of the positive charge that it will be following. Of course, it will be going away from the positive charge and it will be going towards the negative charge. So we can just assume that yes, electric field lines, they are moving from positive charges to negative charges. They are originating from positive charges. They're always going into the negative charge. This is how we define it. That is why. So C is also wrong, but D is absolutely correct. Show the field strength by their density. Now what is this? Their relative closeness of the electric field lines, like this point here and this point here. If I compare point number 1 and point number 2, of course at point number 1 all the field lines are very near to each other, which symbolizes bigger strength for the electric field, and for 2 the strength is lesser. Now this is known as that the relative closeness of electric field lines depict the strength, and that is why D is absolutely correct for this answer. Okay dear students, this is it. Thanks for watching. This is Professor Varun. Keep watching. All the best.